Thank you very much, everyone, for joining. Thank you for joining this event that was scheduled from the Inviso Greece community server, from the community to with the subject building meaningful detection and queries. Um, the presenter today is Dimitirs Binichakis. Dimitirs Binichakis currently is a consultant at Inviso at the CERT department. Previously, he worked for other MSSP providers and cybersecurity firms. He has experience in blue teaming and in the department of SOC. And as I said earlier, now he's a consultant, a full-time consultant at Inviso at the CERT department. And thank you, Dimitris, for taking the time to come and present for the community. And after that short introduction, I will give the floor to you, my friend.
Thank you, Jonathan, for the amazing introduction. So I've gone ahead and prepared a short presentation for you guys called Building Meaningful Detection Queries. It's an introductory course, so you won't find anything too complicated here. So with that in mind, some information about myself. Everybody starts their talks off with who am I. I decided to do a net user just for a change. So as Jonathan mentioned, I'm a security consultant at Inviso, part of the CCERT and SOC team, and more specifically part of the CERT, which stands for the Computer Emergency Response Team. Previously, I've worked at an MSSP as a SOC analyst, and I'm interested in anything that has to do with cybersecurity, but mainly reverse engineering and Active Directory security, and more specifically red teaming. So with that out of the way, let's get to the actual presentation. So what is detection engineering? Detection engineering is a capability to model threats to deliver modern and effective threat detections, which basically means that a detection engineer creates rules that trigger based on certain events and detect malicious activity. What a lot of people don't realize is that detection engineering requires a lot of research. You have to stay on top of things. For example, for the Folina 0 day that came out, you have to be able to quickly understand how the exploit works in order to then create detections so you can find if someone tried to exploit that 0 day in your environment. But yeah, the talk is introductory. I'll explain basic detection engineering concepts and logic. I'll focus more on the logic part and not so much on the implementation. But you won't be finding anything advanced in this talk, such as advanced threat detection queries and such. So let's start off with an example. Before anything else comes logging. The presentation will focus a bit on Azure Sentinel, but the principles mentioned here can be applied to different CMs as well. But basically Azure Sentinel has data connectors, and what data connectors are, they basically enable you to store logs and to parse them in the Azure Sentinel CM. So why is this important? Well, basically, if you want to create a rule that, for example, triggers on DNS requests, the DNS data connector must be enabled. You can't create a detection query for DNS events if you're not logging DNS requests in the first place. So as you can see, there are a lot of data connectors that one can onboard and collect logs from, and I've included a screenshot of the DNS data connector. So moving forward, Let's say you want to start creating rules and enabling rules to help mature your organization's defenses. So Azure Sentinel and Microsoft provides a set of predefined queries and rules called rule templates. As of now, there are around 400 pre-built rules that someone could implement, provided that the necessary log sources are indeed enabled. Data connectors could also be referred to as log sources. They're basically the same thing. If you come from a QRadar background, the term log source might be more familiar to you, but Microsoft refers to them as data connectors. So yeah, Microsoft indeed provides these rule templates, and they're continuously adding more and more. As you can see, this is a screenshot of the rule templates. You've got a lot of different kinds of rules with different severities as well. They could be ranging from high to medium and low, and they cover a different ranges of attack. As you can see, they are mapped to the attack framework as well, and they could cover anything from initial access to persistence, credential access, a lot of different kinds of things. And these rules, as you can see, most of them are scheduled, meaning that they run, for example, once per day, and then you get basically the results from these rules. And of course, depending on the rule, a different data source is required. For example, if something triggers on DNS events, then the DNS data connector must be enabled, as was mentioned previously. So let's take a look at the DNS tunneling example. What is DNS tunneling? DNS tunneling is basically when an attacker tries to exfiltrate data from an organization by using DNS. And how does that work? They basically encode the data they want to exfiltrate in DNS requests. So as you can see, this is a true positive detection of a DNS tunneling attempt. The top level domain is owned by the attacker, and the subdomain is basically the data that gets exfiltrated. In this example, if you were to decode the subdomain, it decodes to the IP and the hostname of the computer that was infected. Of course, this is just an example, so you can get the idea of how a true positive would look like. But if you were an analyst trying to investigate such an alert, you could check the reputation of the top level domain, when it was registered, and how many requests do you normally get towards that domain in your environment. So another thing, of course, that is important is to understand the place of a detection engineer in a blue team. Before the detection engineer, there's another specialist, most commonly referred to as a SOC engineer or a CM engineer, whose job is to onboard the data connectors, and then, and only then, can a detection engineer create rules. And after the detection engineer comes the SOC analyst, which analyzes the detections that were created. So it's a bit like of an ecosystem and a team. And if you want to have a blue team, each person in that regard is of course necessary. So let's take a rule at an example DNS tunneling rule. If you wanted to start detecting DNS tunneling, this could be a good place to start. Basically, what you're looking at here is a rule, and I want you guys to focus on the detection logic and not the implementation. It's a bit like programming, right? If you understand the concept, it's easy to implement it, for example, in either JavaScript or Python. So I don't want you guys to focus too much on the syntax, but to just understand the logic. So what this rule does, it checks for the length of the DNS request, which is named the URI threshold. So as we saw earlier, a true positive detection of DNS tunneling, it's a pretty long request, right? Because you're trying to get data out of an organization. So a common characteristic of DNS tunneling requests is their length. Of course, right here you can see that we're excluding certain IP addresses, mainly localhost, because we don't care about localhost requests, right? The malicious subdomain must be owned by the attacker, so we're looking for mainly outbound requests. And another thing that's really important is to exclude common domains that could trigger false positive alerts. So if you've ever worked at the SOC or a blue team, you may have seen some of these domains get picked up as false positives for DNS tunneling, but basically these are non-malicious domains that could trigger such an alert for DNS tunneling, so it's good to exclude them. For example, there's a couple of antivirus vendors such as Trend Micro or Sophos or McAfee as well, and you want to get those out of the way, because ideally each time a rule triggers, it should always be a true positive detection 100% of the time, which of course is really difficult, but that's what every detection engineer aims to do. So moving on, another similar example, crypto miner infections. So how do crypto miner infections work? Well, when you get infected from a malware that then downloads the crypto mining component, you basically communicate to a public mining pool, which is just a domain. Now, these domains are not malicious per se. For example, monerohash.com. I could go to monerohash, and it's not like I'll get infected or anything. It's just that they could be reliably used to check for crypto miner infections. And one might say, okay, but why not just block a list of non-malicious domains at the proxy level? The thing with trying to block things at the proxy level is that, yes, the communication will get blocked, but an alert won't get generated. So if you create a detection rule for crypto miner domains, you can then detect which computer initiated the request and start the investigation from there, maybe discover other hosts as well. So of course, again, since this is a DNS request, the DNS data connector must be enabled. So here we can see a rule that basically tries to detect DNS requests towards a list of crypto mining domains. There's Monero Hash, as we saw before. There's Monero Farm. There's xmrpool.com. and this is actually a pretty decent query to implement if you want to start looking for crypto mining infections. So before we move on to the next slide, I'd like to ask you guys a question, since I see a couple of skilled people in this event. Let's say you want to create a rule that detects DNS zone transfer attempts. Could you guys maybe walk me through in the event question channel what kind of ideas or detection logic you'd implement for such a rule? So let's say, for example, you're doing a box write on Hack the Box, you see DNS open. Do you just blindly type dig AXFR at the domain and try to do a DNS zone transfer, or do you guys actually understand how zone transfers work? So let's see if there's anyone brave enough to type in the event questions how they'd possibly detect a DNS zone transfer attempt. I'm gonna give you guys a couple of seconds, and if I don't see anyone typing, then I'll give you guys the solution. Alright, so since everyone appears to be quite shy, oh, do I see Froze 830 typing something? Let's see. Yes, that's actually one way to do it. Yeah, that's something you could indeed do. But another thing you could do is DNS typically uses UDP, right? But zone transfer attempts use TCP. So firstly, you could look for DNS TCP requests on port 53. And another way to improve that query is to look at the record type, right? So DNS zone transfers have a distinct record type, which is AXFR. So when you see AXFR record type on a DNS request, then you know that it's a zone transfer request. And another thing you could do to improve this query, typically legitimate zone transfer requests are done between a primary DNS server and a secondary DNS server for synchronization reasons, right? So it would be indeed unusual to have a workstation initiating a zone transfer request. So that's something as well that could be added to the detection logic. So moving on from that, process base64 encoded command lines. So a lot of malware nowadays use base64 encoded commands in order to avoid detection. You can see an example right here. Basically, they'll most likely utilize PowerShell, the encoded command flag, and then a malicious command which is base64 encoded. So let's also take a look at the possible detection for attacks like this. What a detection engineer could do is look for event IDs 4688, which is the process creation event ID, and then you can search the command line for the following strings. For example, this one right here is an encoded PE header file. So it's basically an executable encoded as a base64 command. You could also look for this one right here, which is IEX, which stands for invoke expression, which is also really commonly used by malware. And of course, you could also search for from base64 string, which is indeed another way malware utilizes this command to decode malicious commands so they can be executed. But you might think, okay, why not just alert on the dash encoded command flag and detect malicious PowerShell commands that way? Well, it's because detection engineering is a cat and mouse game, and it has a lot of nuances. For example, indeed the dash encoded command does work, but you could also do it with dash encoded com or with dash enco, or you could also add caret characters and run your command that way as well. So according to Palo Alto and one of their blogs I've added here, there are over 100,000 possible permutations for the encoded command parameter alone. So as you can see, that's why we didn't use the dash encoded command flag. And that goes to show how much thought goes into detection engineering, because these are things you must know, and if you don't, then that provides the attacker an opportunity to bypass your rules. So we're also gonna take a look at MSI-exec lolbeans. What are lolbeans? They're basically built-in Windows binaries that are non-malicious in nature, but their functionality could be abused by attackers. For example, MSI-exec is indeed a program provided by Microsoft, right? It's used to execute MSI packages, but its functionality could be abused by hackers. So for example, you see an example of a command in which MSI-exec is used to fetch a payload from a malicious site. You might have used lolbeans yourselves if you, for example, have played Hack the Box and you're doing a Windows box, right? You've got a low privileged cell and you wanna move on to privilege escalation. You might use cert util to fetch WinPs and execute it. So that's another example some of you guys might have come across or used yourselves. And this is indeed commonly used by worms that spread via infected USB drives. So we're gonna take a look at the rule to detect MSI-exec lolbeans. But this is an interesting one, and we're gonna discuss why. So, indeed, once again, we're focusing on the event ID 4688, which, as mentioned before, is for process creation. And we're trying to match the command line for anything that contains MSI-exec, and following that is a regular expression for the URL, which is basically the dot and // part. But let's say you're a red teamer, right? And you know that the blue team has this rule enabled, and you wanna bypass this rule. Anyone might have an idea of how this rule could be bypassed and why it's not an ideal rule to implement? I'm gonna give you guys a hint, and it has to do with the SpongeBob meme, if you guys have seen that. So I'm gonna go ahead and explain. So hopefully you guys can see my command prompt, right? So I can go ahead and execute a command this way. Let's say I can type who am I, and indeed it works. But I could also type a command this way, and indeed it works also. So since we're matching for something that is case sensitive, this rule could be bypassed by just typing msexec the same way. That's why when creating rules, it's really important to have a case-insensitive mindset. So how could this rule be improved? Ideally, you'd want to include msexec in the process name and match on the process command line only the regex for the URL, which is the dot and the 2 slashes, and leave msexec out of this particular rule. So, okay, we've got all kinds of different rules we discussed, right? So let's get to implementing some rules. Well, when you've got a rule, it's not like you're gonna implement it blindly in a production environment. So Azure Sentinel has this thing called the result simulation, which basically gives you an idea of how many detections and a rule would generate it in your environment. So you could have something that you consider to be a great rule, and when you're about to implement it, it just starts to create a lot of alerts, which is something that you don't want because your analysts are gonna get very angry. So indeed, it's important to keep an eye on these things and tune rules to tune false positives when you see them, and continuously work on improving your rule set. That's pretty much it for my presentation. If you're interested in joining us, we are indeed hiring. We're hiring actually a lot of people, SOC analysts, consultants, and many more. Feel free to ping either Bad Larry, me, or really anyone with an Enviso tag next to their name.
Thank you, Dimitris, for the amazing presentation. Thank you for the interesting topics that you covered. Be sure to check the future events that we will be scheduling. As of now, already we have 2 events that are in the upcoming events channel. If you haven't checked those, please feel free to check those and join. Both I think start tomorrow, but if you can, I think you can still sign up for them. So thank you guys again. Thank you, Dimitris, for the presentation. Thank you for everyone that showed up today, and see you on the next event. Have a nice evening, everyone.